Okay, so we are going to start a brand new chapter titled Chemical Formulas and Chemical Compounds. And so we're just going to talk about how do you name chemicals and how can you write the chemical formula when you're given the name. I am going to break section 1 up into a couple of parts because tackling this all in one video is way too much, and even half of it might be just way too much. So we're going to see how far I get. So the learned objectives for today: explain the significance of a chemical formula, and then determine that formula when you're given two ions, and then if you're given the name, figure out the formula, so vice versa. All right, so we use chemical formulas to indicate the number of atoms of each kind in a chemical compound. We do this with molecular compounds as well as ionic compounds. With molecular compounds, just know that this is not the simplified version, okay? You know, glucose, which is a sugar, the chemical formula is C6H12O6. Sucrose, another type of sugar, is like double that. So it's C12H24O12. So with molecular formulas, it does tell you the number of atoms that the compound has of each type, but when we deal with ionic compounds, it is the simplest ratio of cations and anions, okay? So you can't simplify it anymore, okay? Whereas up here I could. Remember with cations have a positive charge, okay? Cats have paws, and anions kind of looks like the word onions, and maybe some of you don't like onions, so it's a negative charge. So today we're going to focus on ionic compounds. There are two types of monoatomic ions. Sorry, there are two types. I just got distracted by it. So monoatomic ions are when you only deal with one type of atom. Okay, so with our main group elements, which is groups 1 and 2, and then groups 13 through 18, okay, our S and our P block. Groups 1 and 2 tend to lose electrons. And so when you lose electrons, you become positively charged. So on my periodic table, I have like big black numbers that say +1 and +2, +1 above the group 1, +2 above the group 2. So groups 1 and 2 tend to lose, electrons become positive. Groups 15 through 17, so it'd be like nitrogen, oxygen, and fluorine, tend to gain electrons. And when they gain electrons, they become negative, so they form anions. Carbon and silicon, because they're halfway between 8, 1 and 8, tend to share. And then metals tend to lose electrons because of that sea of electrons, so they tend to be positively charged. All right, so naming monoatomic ions is pretty simple. When it is a positively charged ion, all you got to do is say the element's name and then throw in the word cation. So if you're looking at potassium, K+, you just write potassium cation. Or if you were just given the word potassium cation, you would just say K+. And this plus is from the +1 on the periodic table. Magnesium, +2. Okay, so it's just magnesium cation. Anions are a little bit different. You have to drop the ending of it and change it to IDE. So fluorine with a -1 charge, you wouldn't say fluorine anion, you would say fluoride. Drop the INE and change to IDE, and then throw in anion. Nitrogen. Okay, you don't say nitrogen anion, you'd say nitride anion. So here's some common monoatomic ions. Here's my group 1, lithium, sodium, potassium, rubidium, cesium. And to make this more accurate, I would say cations after all of these. Okay, cations. Here are my anions. Notice the endings have already been changed to IDE. Okay, it's not oxygen, it's oxide. It's not sulfur, it's sulfide. It's not phosphorus, it's phosphide. Now, binary compounds means that you're going to have compounds. Compounds are groups of atoms where the atoms are completely different from each other. Okay, so 2 or more different atoms bonded together. So we call this binary ionic compounds. Binary means it's going to have 2 names, a first name and a second name, and the charges of that ionic compound have to be equal. So if I look at potassium iodine, potassium on the periodic table is found in group 1. So it has a +1 charge. Iodine is group 17. It has a -1 charge. The charges balance out. So that means I only just need one of each to have the charges balance out. So to write the chemical formula for this, the symbol for potassium is K, and the symbol for iodine is a capital I. So it's capital K. And I just need one of each, Ki. Sodium. On the periodic table, it's in group 1, it's got +1 charge. Sulfur is in group 16. It has a -2 charge. Oh no, the charges don't balance. So then you ask yourself, all right, what can I do to get the charges to balance? Well, if I just have 2 sodiums, okay, +1 times 2 is a +2. Well, now the charges balance out. I have a +2 here and a -2. Now they equal 0. So you want to make sure it's the simplest, okay? So this is the simplest way to do that, the least common number that they have in common. So when I write the chemical formula, the chemical symbol for sodium is Na, but I needed 2 of them to cancel out this charge. So you're going to write Na2. And then with sulfur, you just needed 1 of them still. So the chemical formula of the sodium bonded to sulfur is Na2S. Now, whenever you come across an odd even one, you need to ask yourself, what's the least common factor that they go into? So here I have 3 and a 2. You just can't like simply double it. It just doesn't work. So you ask yourself, what number do both 3 and 2 go into? And you say, oh, 6. So how many times do you have to multiply this +3 to get to 6? And you say 2 times. So 2 times 3 is a +6. Same thing with oxygen. How many times are you going to have to multiply this -2 to get to 6? Right? So it's 3 times to get to that -6. And now this +6 and this -6 cancel out. So when you write the chemical formula, aluminum is Al. How many aluminums did you need? Well, I took that charge and multiplied it by 2, so it's Al2. And then oxygen is O, but how many oxygens did you need, to get to that -6? Well, I needed 3 of them. So ALO equals Al2O3. Now on the flip side, when you name binary ionic compounds, the first name is going to be the cation. Okay, so here I have NaCl. This is my cation. You just name it as is, sodium. The second name is the anion. There's chlorine. Now instead of saying chlorine, you say chloride. So sodium chloride. Let's look at SrF2. Sr is strontium, so you write it as is, strontium. And then F is fluorine, but you don't say fluorine, you drop the end in and change it to IDE for fluoride. So you just say strontium fluoride. Even though I have 2 fluorines, I still just call it fluoride. Over here, the Al2O3, what we just did up here, how would you name that? What would you call that? Well, the cation's aluminum, so you just write out aluminum. But then the anion is oxygen. But you don't say oxygen. You change the end in to IDE, so it's oxide, aluminum oxide. Now there's one more thing I want to discuss. It's called the Stock System of Nomenclature. Some elements have the ability to have 2 or more different types of cations, or different charges. Okay, so like iron can be +2, it can also be +3. So how can you distinguish between iron with a +2 charge and iron with a +3? Well, we use Roman numerals. Okay, so here I have a sample problem of chromium with a +3 charge and fluorine. And I'm supposed to give the name of the compound formed by the ions. So naming this is actually pretty easy. because they gave me the charges for both. So you just write out the cation, that's chromium, and you look at the charge of the cation, and it's a +3. So it's going to be a Roman numeral 3. And then you look at the anion, and that's fluorine, but we don't say fluorine, we drop the end in and change it to IDE, so it's fluoride. So chromium 3 fluoride. Now how would you write the formula? So Cr 3 plus, got a +3 charge, and over here fluorine's got a -1. So this was kind of easy. Basically, how many fluorines you're going to need? I'm going to have to multiply it by 3 to get to a -3 for the charges to balance. So then Cr, you just needed 1, so Cr, F, how many fluorines did you need? Cancel the charges. Well, you needed 3. So it's going to be CrF3. So I got some more examples on the next page here. Name the ionic compound. So here I have copper bonded to chlorine. And so when you name it, you just state the cation, that's copper. And then the anion is chlorine, but we drop the end into IDE, so it's chloride. So it's copper chloride. Let's try the next one here. Oh snap, what just happened? Sorry, I meant to click on that. Okay, so Pb is lead. So you just say lead, and it's bonded to oxygen, right? But we don't say oxygen, we change the end into oxide. All right, you know what, guys, I'm going to have to back up. Sorry. So you might be wondering, when do you use Roman numerals? Okay. We tend to use Roman numerals if they are transition metals, any element in the D block. Okay. And the sample problems on the next slide just triggered that information because copper can also be +1. So to go back to this copper chloride, okay, here I have copper chloride. Well, chlorine has a -1 charge, but I needed 2 of them to cancel out this cation charge. So if this is a -1 and I needed 2 of them, the overall net charge is a -2. Now, I only have 1 cation, so what's the charge got to be on this cation to cancel out the -2? Well, copper means that it has to have a +2 charge, so technically it would be copper 2 chloride. Lead, Pb, that's in the P block, so we're good here, lead oxide. Co is cobalt, that is a transition metal, okay? So you write the cation as is, cobalt. Okay, I'm just going to leave this Roman numeral blank for now. I is iodine. Well, we don't say iodine, we say okay. So now what's the charge of cobalt? Well, I only have 1 of these and it's a -1 charge. So cobalt has a +1 charge because I only have 1 of it. So it's just cobalt 1. Iodide. I spell that one? Yes, I did. Here. Sorry. Okay, write the formula and the name for the following compounds. So let's write the formulas first. Okay. So here I have a copper with a +2 charge and a bromine with a -1 charge. So +2, -1, what do I got to do? Well, I hope you're saying, hey, we need 2 bromines to cancel out the charge on this +2 charge. Now I have a -2 charge over here, a +2, and the charges will balance themselves out. So when you write it, it's CuBr and a little 2 for the subscript. And then when you name this, you'd say it's copper Roman numeral 2, because copper is a transition, And then it's not bromine, but it's bromide. O-M-I-D. Cool. All right, let's take a look at iron and oxygen here. Write the chemical formula. We've got a +3 and a -2. Oh, it's an odd and even numbers here. So what's the least common factor that they go into? And that's 6. So I'm going to have to multiply this by 2 to get to a +6. And then multiply this by a 3. I picked the wrong time to record. They're washing the floors. To get to a -6. Okay, so when I write the chemical formula, it's Fe. Well, how many irons did I need to get to that +6? I needed 2. And then it's O. Well, how many O's did I need to get to that -6? I took it and multiplied it by 3. Now when you write the name of this, it's iron, parenthesis. What's the charge on iron? Do not write Roman numeral 2. You have to look at the charge. Okay, so here it was a +3. I wrote over it so it looks like a negative. So it's a +3. So it's Roman numeral 3. And then we're bonded to oxygen, but we change the end into oxide. So iron 3 oxide. Whoops. Okay. So that's as far as I'm going to get for part 1 here. Now, I did post a worksheet, and do not do it all. We haven't even discussed polyatomic ions. Okay, but let's just take a look at this. From this assignment, you should be able to answer number 1, okay, number 8, number 10, number 13, and then on the back side, 24 and 25. Oops, I lost it. 24 and 25. And yeah, 24 and 25, as well as 26. Okay, so that's all I want you to do. Try to name and write the formulas for those 7 problems: 1, 8, 10, 13, 24, 25, and 26. And then we'll talk about the polyatomic ions the next time I see you.